In this video, we will use our log rules to separate expressions. So to review, these are our rules for logarithms. And when we go to separate our expressions, our goal looks something like this. So we might get something like a number times a log of x minus another number times a log of y. No multiplication, division, or exponents inside logs. Now, you might be looking at this and wondering, why on earth would I ever want to do that? And the answer is that this is something that you'll want to be able to do for calculus. In calculus, addition, subtraction, and multiplication by a number are really easy to deal with, but multiplication and division and exponents are harder to deal with. If it were 50 years ago, we would also want to know this because we would need it to operate our slide rules. But that's a problem that's unlikely to come up again in the immediate future. So how do we do this? Right. Suppose we have an expression that looks like this. Suppose we want to rewrite this expression using the simplest possible logarithm. Well, we're going to use our 3 log rules to split this up, and we're going to do it in the reverse of the order of operations. So, if we were evaluating that expression, the last thing we would do would be division. So, in splitting this up, the division is the first thing we will deal with. Division becomes subtraction when we split it up. So we'll have the log base 3 of 2 times x squared y to the third minus the log base 3 of the square root z minus 1. Okay, now if we were evaluating this expression, right, the next to last thing we would do would be the multiplication. In this example, there's only multiplication in the numerator, but if there were multiplication in the denominator, we would deal with that as well. So we split up this multiplication here. We'll have log base 3 of 2 plus log base 3 of x squared plus log base 3 of y to the third minus log base 3 of the square root z minus 1. Before the multiplication, we would actually take powers. Now notice that that square root is actually a power, right? That's actually an exponent 1/2. So we might rewrite that at any time. So now there's no exponents in this first term, so we'll just leave it, log base 3 of 2. In the second term, the exponent is 2. That comes out. So we have 2 times log 3 of x. Here we have an exponent 3. That comes out. That's 3 times log 3 of y. And then here we have exponent 1/2. That comes out. That's 1/2 log 3 z minus 1. Now, we still have that z minus 1. If we were evaluating our expression, we would do that first. But none of our log rules tell us how to split up addition or subtraction inside a log. And that makes sense because we don't have any exponent rules for if we're adding together powers of the same base. So in fact, we have to leave the z minus 1 alone. We can't split up addition or subtraction. So our final result, we started with log base 3 of 2x squared y to the third over square root z minus 1. And in the end, we rewrote that as log base 3 of 2 plus 2 log base 3 of x plus 3 log base 3 of y minus 1/2 log base 3 of z minus 1. Okay, I'm going to give you one of these to try now. Use the log rules to rewrite this expression using the simplest possible logarithms. Pause the video and try this now. Okay, so we want to rewrite our expression in terms of the simplest possible logarithms. And as before, we're going to follow the order of operations backwards. So the last thing we would do would be the division, so that's the first thing we're going to divide up. And in writing this step, I've gone ahead and rewritten that third root as an exponent 1/3, just so that we have that in our upcoming steps. Okay, now next we're going to split up the multiplication. And in doing that, we're going to want to note that when we do the subtraction, we're subtracting this entire expression. The reason we want to be aware of that is every term that comes out of this expression will be negative. So, splitting up the part that came from the numerator, we have the log base 5 of x squared plus the log base 5 of x minus 6. And then splitting up the part that came from the denominator, we have the log base 5 of 2, the log base 5 of y squared, and the log base 5 of z to the 1/3. Again, each of these terms is negative because it came out of that second term, which we're subtracting. Okay, and finally we deal with the exponents. Right, so here we have an x squared. That becomes multiplication by 2. X minus 6 we have to leave alone. There's nothing to do to just a 2. Here we have a y squared. That becomes 2 times the log of y. Here we have a 1/3 power. We pull that out as well. And there we go. Our expression is rewritten in terms of the simplest possible logs.